So guys, we're going to talk about evaluating limits today, and I'm going to record this for your classmates that are out as well. So first thing, guys, is we're just going to talk about is direct substitution. And it's just like what it sounds like. If you have a function that's continuous, at that point you're trying to find the limit, you can actually just plug and chug. Okay, so today, hopefully it'll be a little bit easier day for you. So let's look at a couple of examples together. Example 1. Let's say I asked you to find the limit as x approaches 2, okay, and our function is going to be 3x minus 5. Okay, so when you think about this, first thing, guys, is you know this is a line, so you know that you can just say, okay, a line would be continuous at every single point, right? So you can just plug in 2 for where there's an x value. Okay, so you're going to say 3 times 2 minus 5. What do we think our limit's going to be? 1. Very good. So just plug and chug. All right, let's look at another example. Example 2. Let's say I asked you to find the limit as x approaches 4, and it's going to be the third root of x plus 4. Okay, so take a moment and see if you can find the answer. So I'm going to just plug it in, and we should get 2. Very nice. All right, next example, example 3. Let's say I asked you to find the limit as x approaches 1 of sine of pi x divided by 2. So that means you're just going to want to plug in 1 for where there's that x value. So you're just evaluating sine of pi over 2. And what is that going to equal, guys? Marissa, you okay there? You look like you're a little bit confused. Okay, just kind of catching up. So think about in your unit circle, if sine is your y value, pi over 2 means you'll be at 90 degrees. So what would be the value for it? It'd be 1. Very good. Okay. All right, a couple more examples. Let's say I asked you to find, so this is example 4. Let's say I asked you to find the limit as x approaches 7 of just x. What do you think the answer is going to be for this one? Just going to be 7. Good. Don't overthink it. And then example 5, last one for this section. Let's say I asked you to find the limit as x approaches 7 and my function is just 3. What do you think the answer would be in this case? Think about y equals 3. What sort of graph is that? Yeah, it's just a horizontal line, so it'd just be 3. If I said the limit is x approaches 1,000 of my function 3, what would it just be? 3, okay, because your output is always 3. All right, so let's next talk a little bit about some properties. So Roman numeral 2 is I'm going to actually have, before I give you an example, I'm going to have you go through and kind of think about what properties hold true for limits. Okay, so you can put down Roman numeral 2, and then in your syllabus packet, go ahead. We didn't have time to do the discovering limits the other day, but go ahead and flip to page 6, and you're going to kind of think about what are some properties of limits using graphs. Okay, so let's go ahead and at least do one together and kind of see how you do. And we can come back together and do the other ones. So it says, use the graphs of f and g to evaluate each of the following limits if they exist, if it exists. If the limit does not exist, explain why, and then explain the properties of the limits that are applied. All right, so this first one here, guys, the limit as x approaches 2 of f of x plus g of x, all that you're going to do is you're going to say, okay, if I look back up at this graph for f of x, as we approach 2, what does my limit seem to be for f of x? 2, right? Okay, so I'm going to put down here, it would be 2 plus, and now I need to go to my graph g of x. So I'm going to go over to g of x, and as we approach 2, what does it seem to be? So as we approach 2 from the left and right, what does it look like, guys? Negative 3, right? Okay, so I'm going to put down there 2 plus negative 3, which just give me negative 1 overall. Okay. So why don't you guys take a moment, work through these. If the limit does not exist, please state why, or why you think it doesn't exist. Okay.